Hello Year 10s, this is the marking of the electricity exam. Make sure you have your blue pen and your green pen ready to mark the exam. So, the first question says, draw a diagram of to show 1.5 volt cells connected together to give a potential difference of 4.5 volts. So if we do 4.5 divided by 1.5, we see we are looking for 3 cells to make a battery. So your 3 cells could be either drawn like this or like so, but your 3 cells definitely cannot be drawn like this. It needs to have the 2 lines on either side, and also not like this as well. So make sure you have 3 long lines and 3 short lines when drawing your 3 cells. Next question, you had to label parts A, B and C. A is a motor because it has an M inside. C is a voltmeter, and here we have a fuse. It's a fuse because the line goes right through, unlike a resistor. Question 3, a student built a circuit like this below. You have to calculate the total resistance of the circuit in the diagram. So the total resistance using this equation. Now, I've also added in the equation that we use in school here, and the numbers are so. The potential difference is given by the voltmeter here. The current is given on the side here by usually what would be an ammeter. Now you would think that the resistance is 3.5. However, this is the total resistance of the circuit and you're looking for it. So therefore we are calculating the total resistance like so. And if we put it into our equation, V equals I times R. V is 12, I is 1.6 times by R. We divide 1.6 on both sides, and our final answer is 7.2 ohms. Next question here. We had to calculate the resistance of Q. Now, we know the resistance, the total resistance is 7.2, and we've been given here P is 3.5. Therefore, Q will be 7.5 take away 3.5, and our final answer is 4 ohms. Next, the student connects the 2 resistors in the diagram as parallel. Remember, parallel means that there are nodes or junctions, you could say, and current can flow more than one path, through more than one path. We also know in parallel circuit, resistance is less than the lowest individual resistance, or you could say there's more than one path for charge to flow, current to flow. So what happens to the total resistance of the circuit? Well, it will decrease because it's less than the lowest individual resistance. Give a reason, as I said here, resistance is less than the lowest individual resistance. So current is going to increase because they are inversely proportional. Here we have an electric circuit, question 4. The diagram is shown the switch in an open position. So closing the switch will complete the circuit. So you're aware we have a battery of 2 cells, we have an ammeter, we have the switch, we have a resistor, a voltmeter, and a variable resistor. This is the test circuit. It's really important you know this is the test circuit for a resistor. Okay, really key that you know this circuit off by heart. Charge flows the completed circuit and the reading on both the ammeter and voltmeter. Here we have in 10 seconds, which is the time, 20 coulombs, which is the charge that flows through, and we are calculating the current. And as I've already written here, the current calculation is Q equals I times T. So we're looking for the current in amps. We add in the correct numbers, and we need to divide 10 by both sides. So 20 divided by 10 is 2 amps. For 20 coulombs of charge we used through the resistor R, 100 joules of work must be done. So we know coulombs is Q, we know joules is energy, and we're looking potential difference. So this is our equation that we use, E equals Q times V. We fill in our numbers, 20 coulombs, 100 joules potential difference question mark V. We insert and substitute our numbers in. 100 equals 20 times V. Divide by 20 on both sides. The answer is therefore 5 volts. Here is another simple circuit. We have to, well, firstly, when you see a circuit like this, we need to recognize this is a series circuit. And we know that because there are no nodes or junctions, current flows in one path. So no junctions, current flows in one path. We are calculating the total resistance in the circuit, where we know our total will be the two added together, so 9 plus 6, which is 15 ohms. Next question, we have to calculate the reading on the voltmeter, and I've just written to remind myself, voltmeter measures potential difference. So we have to use our numbers. So let's find out. The voltmeter is what we're looking for, so we don't know that in volts. We've got our ammeter reading, and then we've got these two added together to make 15 ohms as our resistance. So here we should have resistance, which is 15 ohms, and 0.3 amps for our current. We do V equals 0.3 times by 15, and the answer should be 4.5 volts. Next question. Draw a ring around the correct answer to box to complete the sentence. Replacing one of the resistors in a series circuit, remember, will increase. So if I change one of the resistors, so at the moment we had a resistor which was 9 ohms and 6 ohms. If I replace one of them with a higher value, let's say I change this to 10 ohms, here was 15. If I change that to 10 ohms, so the first one, if I change it to 10 ohms, it's going to increase to 19, so therefore it will increase there. Next question, we had a fuse. We had to find out what the fuse is. Well, the fuse is this one here. We have an LDR, a diode, and a thermistor. The appliance is connected to mains electricity supply. The mains is 230 volts. Calculate the energy transferred when 13 coulombs of charge flows through the appliance. So we are calculating the energy, that's our E. We have a potential difference, which is V, and finally the charge that passes through is Q. So we're using this equation, E equals Q times V. Substituting our numbers in, we have E equals 13 times 230, and finally our E is 2,990 joules, and that's the final answer for the energy transferred. We have a diagram of a fuse. A fuse will break the circuit if too much current flows. More specifically, the fuse will melt. Now, if the fuse melts, we'll come back to the question. Oh, here we are. The fuse wire melts. So we are looking at 1.52 coulombs, and the fuse is 0.4 seconds. So this is the charge, and this seconds will be time, and we're calculating the current. So these three letters should make you think, okay, I know the equation is Q equals I times T. Q is 1.52 coulombs, and time is 0.4 seconds. Substitute the numbers in, equals I times 0.4. And we should get our final, we divide by 0.4 on both sides, and we should get our final answer is 3.8 amps. Final question, question 7, slightly trickier one. This circuit was set up. The first thing you need to say is, what type of circuit is this? Well, this circuit we know is a parallel circuit. And here we have a table of current through the 3 ammeters, and I've added those numbers in. I've put 0.2 up here, 0.6 here, and 0.3 amps here, and we are looking at what the readings are for these 2 ammeters on the side. Well, let's look backwards. We know it all starts at this point here, and they are moved through the different paths here. So if we took 0.6 and 0.3, we know if we go backwards, we will find the number for this ammeter here. So we started here, back we go, and we know that this number, this ammeter 4, will be the addition of 0.6 and 0.3. Therefore, the answer is 0.9. ammeter 5 will be the addition of 0.6, 0.3 and 0.2. So ammeter reading 5 will be the addition of all of them, which is 1.1. The reading on the voltmeter is 12 volts, so the potential difference stays the same in a parallel circuit, remember. So if the reading here is 12 volts, it will also be 12 volts here, it will also be 12 volts here, also be 12 volts here, because it stays the same in a parallel circuit. You need to find the resistance of R2. So we are finding the resistance of this path here. We know the potential difference is 12 volts. We know the current is 0.6 amps. Therefore, if we put it into our equation here, 12 equals 0.6 times by R. We divide 0.6 by both sides. Our answer is 20 ohms. You must include the units, ohms, to get the final mark. Final question. The circuit above, resistor 2 is burnt out and completely stops the current flowing. There is no other change in the circuit. We need to complete the table to work out what would be in A3, A4 and A5. So going back to our circuit here, we know, and we've written here, that R2, the path is completely gone. Okay, so there is no current going through that path there. Now, the first thing we need to note is that A5 is going to stay the same. No matter what, A5 will still have 1.1 amps flowing through A5. We know that that's already been flowing through. So therefore, we can work out the rest. If 1.1 amps flows through here, 0.2 is going to go down this path here. So the rest will flow down this path. And therefore, the rest flowing down this path will be 0.9 for ammeter 4, 0.9 amps. So now we've worked out this is 0.9 amps flowing through here. And we know this path is completely gone. We remove that path, therefore 0.9 amps is now also going to be flowing through A3 as well. And so A3 will also be 0.9 amps. So make sure you count up your marks, and your final marks goes at the top for your teachers to see.